In this video, we are going to go over target 1.6. I can use dilations to create similar figures. So what is a dilation? A dilation is a transformation in which a figure is enlarged or reduced by a given factor around a given center point. In this class, we're not going to worry too much about what that center point is. The biggest thing is a dilation makes your figure bigger or smaller. Okay, so we can see here we have this first triangle that has 2, 4, 6, right? And I can make it bigger, and you can see here I'm multiplying all of my numbers by 2. So it goes 4, 8, and then 12. Or I could make it smaller, right? If I have 2, 4, 6 and multiply all my numbers by 1/2, then they all get smaller. And that is our factor, or our scale factor. Okay, that number that we multiply all of them by that either makes it bigger or larger is our scale factor. One other thing we need to know is that if you have an enlargement, as we saw, if it gets bigger, it means your scale factor, which is often represented by this letter K, is greater than 1. And if it's a reduction, that scale factor is less than 1. One thing is that K can never be negative. Okay. So let's look at an example. We are going to dilate our triangle by 3, and then is this an enlargement or a reduction? So here I'm going to look at my triangle, and basically all I'm doing is I'm taking each number, so I have 2, and I'm going to multiply it by my scale factor. So 2 times 3 is 6. 5 times 3 is 15. And 6 times 3 is 18. Okay? So these are the new sides of my triangle. So I'm going to try and create a triangle that looks just like this, only bigger. That wasn't a straight side. And now my sides are 6, 15, and 18. So is this an enlargement or a reduction? Well, I went from a triangle this size to a triangle this size, so this is definitely an enlargement. First of all, because all of these numbers are bigger. 6 is bigger than 2, 15 is... Oh no. Sorry about that. We should put the sides corresponding. This side is 15. This side is 18. Sorry about that, guys. 6 times 3 is 18, and 5 times 3 is 15, right? So I get bigger numbers. Also, because my scale factor, 3 equals 3, is bigger than 1. So either reasoning, you can say, oh, it looks bigger, but also remember when your scale factor is bigger than 1, then it's an enlargement. That's really it. Okay. Again, like we did before, we would just check these, right? If I divided all of these, we'd get that scale factor 3. So this is very similar to what we did with similar triangles, right? It's just kind of like now I'm creating a similar triangle instead of checking that they're similar. All right, example 2, we're going to graph KLP with vertices at K, -4 is -6, L, 0, 4, and P, 4, -6. And then we're going to dilate triangle KLP by a scale factor of 1/2 and centered at 0, 0. Again, that center doesn't really matter much. All the ones we're going to be doing in this class are going to be centered at 0, 0. So, we're going to first start by graphing our points. So we have K is at -4, -6. I'm going to label that as K. L is at 0, 4. And P is at 4, -6. And that is P. The last thing I should do is this is triangle. This isn't 3 separate points, KL and P. This is triangle KLP. So make sure when you're doing these that you do actually create the triangle at the end. Okay, and I'm going to dilate this by 1/2. So what we do here when we have points is I take those points. So K is at -4, -6. And I multiply the points by our scale factor. And how we multiply a point by a scale factor is, well, we get a new letter we call that little apostrophe prime. So I would call this K prime. And I'm basically multiplying that both of these points by 1/2. I kind of think of it as distribution. Not really, but that 1/2 is going to be multiplied by both of your points. So -4 times 1/2 is -2. And -6 times 1/2 is -3. So I can go to -2, -3. And that's K prime. Same thing with my 2 other points. So I have L. L is at 0, 4. I'm going to multiply by 1/2. I get L prime. 1/2 times 0, well, that's still 0. 1/2 times 4 is 2. My last point is P, which is at 4, -6. I multiply by my scale factor. And I get my P prime. Well, 4 times 1/2 is 2. -6 times 1/2 is -3. So we have +2, -3. Doesn't like P for some reason. And that's P prime. Maybe find the other one on my K over here. Oh, he doesn't want to connect those. There we go. K prime. All right. So then again, just like before, I'm graphing triangle, the dilation of the whole triangle. So I need to connect my points. Okay. So that is the dilation. And again, here we can see. We think about it either way, right? My scale factor is 1/2, which is smaller than 1. And you can see that your triangle got smaller. So this would be a reduction. Okay. Let's look at example 4. Determine whether the dilation from A to A prime is an enlargement or a reduction. Then find the scale factor. So in my mind, this looks like a reduction. If I'm going from A to A prime, right, then it looks like my triangle is getting smaller, but I'll find my scale factor first, right? And just like we did before, when I dilated it, I took every number here and multiplied by some number k. Right, if we go back up to here, right, I took every number and multiplied it by the same thing and got my new numbers. So we're just going to kind of do the opposite here. So I start with 6. Times some number k is going to equal my new number, 1.5. I only have to do it once. That k, as soon as I find that k, it's going to be the same for all of them. So it doesn't really matter which sides you choose. Okay? So 6 times k equals 1.5. I want to solve for k. So easy enough. I'm going to divide by 6. Scale factor worksheet that I was pulling questions from. So we'll do 1.5. And we get 0.25. Again, you can put it as a decimal or as a fraction. So k equals 0. And again, I don't need to worry about the other sides, because if I do 9 times 0.25, I'll get that. And if I do, my dad's was 9. No, 9. Sorry, times 0.25 gives me 2.25. Ignore that part. Okay. All right, one last example. Kind of the same thing, but now we have them as points, right? So determine whether the dilation from triangle, I grabbed a different example, so I'm going to say from A to B is an enlargement or a reduction. Then find this, then find the scale factor. That's what we forgot to do up here. We forgot to write our final piece of it saying, oh, my scale factor is 1/4. This is definitely a reduction. That's okay. We talked about it at the beginning, but it's good to know, like, oh, my scale factor is less than 1, reduction. So now, determine whether dilation from A to B, so going from A to B, is an enlargement or a reduction. Then find the scale factor. Okay. So when you have a graph like this, just like above, we only had to choose one side. Now I only have to choose one point. So I can choose any of my points. I'm going to choose this point here, which is at -9, -3. Again, times some k is going to give me my point on my other triangle, which is this point here. Doesn't like me making a point. There we go. Which is at -12, -4. So again, I would distribute this in And because this works as like two separate things, I only have to, again, focus on one. So I can just know then that negative 9 times k is going to equal negative 12. So I'm just focusing on my x value. And that's fine. Okay, so once you have that like set up, you only have to choose like your x or your y. And then just solve. So I'm going to divide by negative 9. And using my Desmos, divide by negative 9. And that equals 1.33333 repeated, or you can put it as a fraction, 4/3. So there is my scale factor. So again, is this an enlargement or a reduction? Well, again, from the picture, I can see from A to B that it's getting bigger. So it is an enlargement. Also, just for the scale factor, 4/3. 4/3 is greater than 1. A good way to know if a fraction is bigger or less than 1 is if the numerator is bigger or less than the denominator. If the numerator, the number on top, is bigger than the denominator, it's more than 1. If the number on top is less than the number on bottom, it's smaller than 1. Okay, so since 4 is bigger than 3, it's an enlargement. And that's really it for scale factor. Okay? Otherwise, I will, you can work on your 1.6 activity or worksheet. And that's it.